In this video, you will learn about quadrilaterals and how to determine its type given the vertices. But before that, let's define what a quadrilateral is. A quadrilateral is a polygon that has 4 sides, 4 angles, and 4 vertices, and the word itself is derived from the Latin word quadra or quadri, means 4, and then latus means side or sides. Now let's talk about the properties of quadrilaterals. Quadrilaterals have 4 vertices, have 4 sides, and the sum of all interior angles is 360 degrees. Right, if this is our quadrilateral here, okay, the sum of the interior angles is equal to 360 degrees. So we just have to add up all the angles here, and they have 2 diagonals. Right, those are the 2 diagonals. And a quadrilateral can be regular or irregular. Regular means they have 4 equal sides, 4 equal angles, and their diagonals must bisect each other. And only square, which is a type of a quadrilateral, that is the only quadrilateral that satisfies all these conditions of a regular quadrilateral. Now let's talk about the types of quadrilaterals. Alright, these are the types of quadrilaterals: parallelogram, square, rectangle, rhombus, trapezoid, and kite. And actually square and rectangle and also rhombus are types of parallelograms. Okay, that one is a parallelogram, and this one in blue is the square. Then we have the rectangle, rhombus, trapezoid, and kite. Now let's solve some problems here. Alright, so we're given here the vertices of a quadrilateral, and we just have to determine which type it is. So the first thing we do here is we plot all the vertices or the points given here, and then we determine whether the sides are parallel or and equal. Alright, let's do that. So we have point B, that is negative 4, 4, so it should be somewhere here. Okay, so this is point B. And then point E is 2, 3, so somewhere here. And then point A, 5, 0, 1, 2, 3, 4, 5. So this is point E, and point R is negative 1, 1. So R is somewhere here. Now let's connect all the points so we can have a picture of the quadrilateral. So we connect B to E, then E to A to R, and then R to B. Alright, we already have a picture of the quadrilateral, but we don't exactly know which sides are parallel or equal. So in order to determine that, we need to solve for the slope using the slope formula, and then the distance between 2 points to determine whether the sides are equal. The slope would determine whether the sides are parallel. If the slopes are equal, then the sides are parallel. Now let's solve for the slopes first. So the slope of points B and E, or segment BE, so this is just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this is 3 minus 4 over 2 minus negative 4, so this is negative 1 over 6. So that is the slope of BE. Now the slope of EA, points E and A, that would be 0 minus 3, and then 5 minus 2. So this is negative 3 over 3. This is equal to negative 1. And then the slope of AR, that is 1 minus 0, negative 1 minus 5, so this is just equal to 1 over negative 6 or negative 1 6, and then the slope of BR, which is just 1 minus 4 over negative 1 minus negative 4. This is just negative 3 over 3 and equals negative 1. Okay, have you noticed here that the slope of BE and AR are equal, and then the slope of EA and BR are also equal? So that means that side BE is parallel to side AR, and then side EA is parallel to side BR. Alright. Okay, now let's draw a line here for BE and AR, a different color to determine, to show that they are parallel. Okay, BE and AR. And then for BR and EA, okay, you can use another color here. Alright, so what's this one? Now we know that the two pairs of two opposite sides are parallel. We now need to determine whether which ones are equal. So we need to solve the distance from one point to another point to determine whether the sides are equal using the distance formula. Alright, now let's solve for the distance between 2 points to determine whether the sides are equal. So let's start with the distance from B to E. So distance of point B to point E. So this is just the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that would be 3 minus 4 negative 1 squared plus 2 minus negative 4, so that is 6 squared. So this is just the square root of 1 plus 36, which is equivalent to the square root of 37. And then the distance from point E to A, right, so this is the square root of 0 minus 3 is negative 3 squared. 5 minus 2 is 3 squared, so this is just the square root of 9 plus 9, or square root of 18. And then the distance from point A to R, so that is the square root of 1 minus 0 is 1 squared plus negative 1 minus 5, that is negative 6 squared. So this is just equal to the square root of 36 plus 1, or square root of 37. And then the last side is distance from point R to B, or say BR. This is just the square root of 1 minus 4 is negative 3 squared plus negative 1 minus negative 4, so that is negative 1 plus 4. So this is 3 squared, so this is just equivalent to 9 plus 9, or square root of 18. Okay, we notice here that the segment or side BE is equal to side AR, and then side EA is equal to side BR. So we can write this as BE, side BE, or segment to BE is congruent to segment AR, and then segment or side EA is congruent to side BR. Okay, so now we have proven that the two opposite sides are parallel, and then they are also equal. So going back to the properties of quadrilaterals, the properties that, okay, the types of quadrilaterals that have these properties are the parallelogram and rectangle. Now, how do we distinguish whether this one is a rectangle or a parallelogram? Okay, now we need to solve for the diagonals. This one. All right. So we use the distance formula to solve for the distance of the 2 points in these two diagonals. So if the diagonals are equal, then that means that is a rectangle, and if it isn't equal, then that means this quadrilateral is a parallelogram. And another thing to distinguish a parallelogram from a rectangle is that a parallelogram has opposite sides equal. A rectangle has the same, opposite sides equal, but with all its adjacent sides being perpendicular to each other. So that means that all angles of a rectangle are right angles, whereas a parallelogram does not have all right angles. Our figure here, after plotting all the points and connecting all the points, shows that it is a parallelogram, but you cannot really exactly tell until you prove it by solving it. So let's prove it by solving for the length of the diagonals. Again, like what I said, if the diagonals are of equal length, then that means this figure is a rectangle. If they are not, then that means this figure is a parallelogram. All right, so the diagonals would be from point R to E, so that is RE, and then point B to A, or BA or AB. Okay, let's solve for that one. All right, the distance from B to A, or AB, B. So that would be the square root of 5 minus 4, of 5 minus negative 4, so that is 9 squared, plus 0 minus 4, negative 4 squared, so this is 81 plus 16. This is just equivalent to square root of 97. So this is the distance from B to A. And then the distance from R to E, or ER, that will be the square root of negative 1 minus 2, that is negative 3 squared, plus 1 minus 3, so that is negative 2 squared. So this is just 9 plus 4, which is equal to the square root of 13. Alright, so we got square root of 97 and square root of 13, and they are not equal. So that means diagonal, or segment BA, is not equal to segment ER. The two diagonals are not equal, therefore this quadrilateral is a parallelogram. Alright, let's solve another example here. Alright, given these vertices here, we plot the points first. So we have point H, that is 0, 2, is somewhere here. And then, okay, so this is point H. And then point J is 2, 6. So 2, 4, 6. Somewhere here. This is point J. And then K, point K is 6, 4. 2, 4, 6. Okay, somewhere here. So this is point K, and then L is 4, 0. Okay. And then let's connect the points. Alright, the figure here looks like a square, but we cannot tell. We cannot tell by just looking at the figure. So we need to prove that all sides are equal, and then that the opposite sides are parallel. Okay, so let's solve it using the slope formula again. So we solve for the slope of point H. So this is point H and J. So that is from H to J, that is 6 minus 2 over 2 minus 0. So this is 4 over 2 equals 2. And then the slope from point J to K, so this is 4 minus 6, 6 minus 2, so negative 2 over 4, or negative 1/2. And then the slope from point K to L. KL, so this is 0 minus 4, 4 minus 6 is negative 4 over 2, negative 4 over negative 2, this is just equal to 2, and then the slope from point L to H, or HL, so that would be 0 minus 2, and then 4 minus 0, negative 2 over 4, this is equal to negative 1/2. Okay, now the slopes determine whether the sides are parallel. So if the slopes are equal, then that means the sides are parallel. So side HJ, or segment HJ, is equal to that of KL. Therefore, HJ is parallel to KL. And then JK and LH are parallel. All right. Okay, and this is one of the properties of a square. Now let's solve for the distance between 2 points. If all of the sides are equal, then we've proven that this figure here, this quadrilateral here, is a square. So let's do this. Alright, the distance from point H to J, so this is just the square root of 2 minus 0 is 2, then 2 squared, plus 6 minus 2 is 4, that is 4 squared. So this is just the square root of 4 plus 16, or square root of 20. And then distance from KJ, or JK, is the square root of 6 minus 2, that is 4 squared, plus 4 minus 6, so this is negative 2 squared, so 16, plus 4, so this is square root of 20. And then a distance from K to L, this is the square root of 4 minus 6, so negative 2 squared, 0 minus 4, negative 4 squared, so this is the square root of 4 plus 16, and that is also square root of 20. And lastly, the distance from L to H, or HL, that is 4 minus 0, 4 squared, 0 minus 2, negative 2 squared, so this is just the square root of 16 plus 4, which is also equivalent to the square root of 20. Okay, based on what we have solved here using the distance formula, the distance of all sides, or all of the sides, have lengths equal to square root of 20. Therefore, this quadrilateral here is a square. Alright, I put some uh, practice problems here for you to work on and for you to practice.